Hello everyone, welcome to the YouTube channel Mission at Physics Exam. So guys, today in this video we will be discussing classical mechanics in our series that is Sure Success in GATE 2023 exam. So this will be even important for your CSIR NET exam and other similar exams too. So if you are doing the preparation for any such exam, you can watch this series and the videos we are going to have in it. Also guys, if I'm going to talk about the slide you can see right now here on the screen, this is regarding the latest offer which is going on Unacademy, and the offer is just valid till 31st January. To grab this offer, you can use and apply the referral code that's Anjali A Live as mentioned here on the screen. You can save 20% on CSIR UGC net subscription and get additional validity of 12 plus 3 and 6 plus 1 months. Also guys, what are the benefits you will get, all that have been shown here on the slide too. And price rise can take place on 1st February. So if you want to take the subscription, because in upcoming days so many new courses by the top educators will also be starting on Unacademy, then to join the sessions of these new courses, the batch courses, you can take the subscription. Or even if any of your friends were waiting to take the subscription, let them know about the offer too, so that they will be able to grab it. And let them know about the referral code as well, that's Anjali A Live as it has been mentioned here on the screen, because by using and by applying the referral code they will be able to get the discount in the total subscription amount, or they will be able to grab the offer. Also guys, rest of the details about the offer have been shown here on the slide. You can have a look at that too. Now let's continue the discussion. This slide is regarding the Plus, Iconic and the Lite subscription differences. Even now the notes are available on the learning app, so you will be able to check out these notes too, along with the benefits you are going to get after taking the respective subscription. Okay, for the Plus and the Iconic subscription, you will also be able to check out the notes as well. And rest of the benefits which you will get have been shown here on the slide. Now let's continue the discussion and let's take the first question from the classical mechanics, which we will be covering in this video today. And the questions we are taking here in this series guys, all are very much important for your upcoming GATE exam, and you can also expect the similar type of questions in your exam too. Now the Hamiltonian for a particle of mass m is h is equal to p square upon 2m plus kqt, where q and p are the generalized coordinate and momentum respectively t is time and k is a constant. For the initial condition, q is equal to 0 and p is equal to 0, at t is equal to 0, qt is proportional to t to the power alpha, the value of alpha is dash. And you just need to write the answer. There is no option because it is NET type question. So this is from the previous years we are going to have. Now let's continue the discussion, or even if somebody is going to get the answer before I will be ending the discussion part, so you can write in the comments 1 and dash whatever is the answer, you can just write it here. Okay, now have a look at this. Hamiltonian is given to you. You need to find the value of alpha where q is proportional to t to the power alpha. And all the conditions have been given, that q is equal to 0 and p is equal to 0 and t is equal to 0. So what we can do in this case, it's going to be, we know that q dot, that is dq upon dt, is equal to what? Delta h upon delta p. So dq upon dt, okay, we will take that, is equal to what? That's going to be, this is the Hamilton's equation of motion I have written, that will be giving us p upon m. So when I will just cross multiply and integrate, I will be getting q is equal to pt upon m plus c. But if you will see that at t is equal to 0, q is 0 as well. So when I will put t0 and q0, I will be getting c0, which means this will be 0 itself. I will just have this much value of q. Same way, I'm gonna have the next equation, that is p dot is equal to minus delta h upon delta q. So it will give you minus kt. So p will be minus kt square, okay, upon 2. This is what you will have, plus d as a constant. So at t is equal to 0, p is also 0 as per the given information in the question. So d will be 0 as well. So that's going to give you p is proportional to t square, which means here you will be just writing it. So t square into t, that is t cube upon m. So q will be proportional to t cube, okay, because you have to take the p dependency on t as well to get the final dependency. So what will be your answer? It will be 3. That's how you're just going to get it. Tell me if in case any step is not clear to you or anywhere there is any doubt, we can talk about it. But if you're going to get this, that's great. That means we can take the next question too. But if there is any question or query, just mention that. I'll be talking about it as well. I will be writing the next question now after this. And since these are the questions from previous year's GATE exam, they will be helping you a lot to know about what type of questions you can expect and you can have in your upcoming exams too. Excuse me. So our next question is, a planet of mass m moves in a circular orbit of radius, that's going to be r naught, in the gravitational potential Vr equal to minus k by r, where k is a positive constant the orbit angular momentum of the planet is. Okay, this is what you have to find. Options are 2 r naught km. This is second question. So if you will be getting its answer, you can write in the comments second and whatever option is correct according to you. 2 r naught km. Option C is r naught km. Option D is root r naught km. Now, if I'm going to talk about the process for finding the answer for any such type of question, so it is a planet of mass m moves in a circular orbit, okay, of radius r naught. So once they have said circular orbit, and now next, this is the key word, in the gravitational potential, there is V as a function of r given to you, where k is the positive constant, and now they are talking about the orbital angular momentum. So in any time, like if in any of the questions you will have the information or something like orbital angular momentum mentioned, in that case what you have to do, you have to consider the effective potential instead of just taking the given potential, and the formula for that is j square upon 2mr square plus vr. So what is j? J is the angular momentum here, and rest we are going to have all these parameters. What we can do now, that's going to be j square upon 2mr square plus vr, that is minus k by r. What we will do next, delta v effective upon delta r we will equate with 0 to get the equilibrium point, It will be giving us j square upon mr cube with the negative sign after differentiating, plus k upon r square. This is what we will have, equal to 0. Now what you can get, you have to get the j value. So j is equal to what you will have. It's going to be mr cube k upon r square, that is mrk you will have within the square root. So your right answer will be root r naught km, because r is equal to r naught you can take as it is mentioned here, hence your option D will be the correct one. If in case they will ask something else, so the initial process will be remaining same, and rest whatever they will ask you to find, you can find, okay, by taking the common general steps. So this is what you can follow and you can do to get similar kind of questions answer. Now let me know if in case there will be any doubt you will have, we can consider that part as well. But if it will be clear, we can go for the next question too. The next question which we will be considering is this. It may even provide you some additional information. In a central force field, the trajectory that's going to be of a particle of mass m and angular momentum L in plane polar coordinate is given by 1 upon r is equal to m upon L square 1 plus epsilon cos theta, where epsilon is the eccentricity of the particle the particle's motion which one of the following choice for epsilon gives rise to a parabolic trajectory. Options are these ones. This is epsilon lying between 0 and 1, and epsilon is greater than 1. Now one thing you need to know, that for the parabolic trajectory, the epsilon must be equal to 1, okay? And that's how your right answer will be option B. One more thing you can do, guys, when you are gonna get any such type of question, or you are getting like something related to that, even you can prepare. So for your next exam, you can get ready with some more details, means some additional information related to the topic can be done, okay? So this is going to be the way you can consider or include more information in your like preparation part. So option B will be the correct one, because for parabolic trajectory, it's epsilon is equal to 1 we should have. This is what we will be considering in this session today, okay? And we'll be doing more important discussion in upcoming classes. So till that point of time, guys, if you don't want to miss this offer, or you want to let your friends know about it, this is just valid till 31st January. So you can let them know about it. They can use and apply the referral code that's Anjali A Live as mentioned here on the screen to grab this offer and can get it. Okay. So thank you so much everyone for joining the session or for watching this video till then.